Welcome everybody. Thank you for joining us for our presentation, Big Data for Marketers, presented by Maithily Erande. This is Greg Olston here with IV Exec, and I'll be helping to moderate the session today. So I'd like to now take this opportunity to introduce our presenter. Maithily Erande is a lecturer at the Zicklin School of Business at Baruch College with a professional background as an analytics expert and a product manager / vice president for product engineering with several Fortune 100 clients, including Apple, Microsoft, Dun & Bradstreet, JP Morgan Chase, Cisco, and Sesame Street. Her professional sweet spot is digital media analytics to launch dashboard products in the media space to help clients understand the value proposition of organized and actionable information. Some of the real-world problems Maithily has solved across the globe in the finance, media, and telecom domains include real-time big data analytics, cross-platform media analytics, enterprise risk management, and global financial data warehousing. Maithily received her bachelor's in engineering in India and her MBA from INSEAD in France and Singapore. We're going to now hand the presentation over to Maithily, and then also a little bit later we'll be joined by Andy Grind, the academic director of Baruch's Executive Masters in Marketing. So thank you very much, Maithily. We're looking forward to the presentation.
Thank you, Greg. Welcome, folks, to the webinar on Big Data for Marketers. We at Zicklin School of Business are very excited to share with you big data concepts and how it has influenced marketers in terms of how to uniquely understand customers, connect with them, and influence your future marketing strategies. As we begin our journey, I want us to spend a few seconds on the slide that's up here. And what this shows is the amount of data that we post or that comes to us every single minute of the day. I'll just walk you through a couple of examples. For example, up north on your 12 o'clock angle, you see Facebook users like, which is about 4.1 million likes every minute of the day. Let's do a quick math here. It comes to about 240 million an hour and about 5.7 billion likes a day. Now, why is this really interesting for us and especially for Facebook? What Facebook does is it uses all of this data internally to analyze what other posts, what other suggestions that it can start giving you. And more importantly, what based on these likes, it reaches out to its advertisers to figure out what are the sponsored ads that should come through to your feed. And essentially advertising or the revenue through advertising is where Facebook gets its bread and butter. So again, very interesting to figure out the number of likes in a day. Similarly, around your 4 o'clock on your screen, we see the Apple users download. It's about 51,000 apps a minute. Again, doing a quick math, comes to about 73 million downloads a day. Again, very interesting for a company like Apple. What it does is it uses this number or this kind of data across the downloads to influence across the industry on the number of apps that need to be developed for Apple. Again, that results in the revenues for Apple itself. So as you again look across the screen, you'll see Amazon, Netflix, Skype, a lot of the social media outlets that you're probably currently using as well. So that's the amount of data that comes to us every single minute of the day. What this huge amount of data has done is it has brought marketing closer to the field of science. People used to think science is separate and marketing is separate. However, with this amount of data coming at us, marketing has gone much closer to science. And organizations are increasingly being forced to look for more than just look at a trend, a past trend in the data, but they're being forced to use much more of statistics and use a lot of algorithms and the knowledge of consumer behavior to truly understand the data and how to progress your organization. I wanted to start off with showing we have all of this data that we just saw coming at us every single minute. Now, how do we actually use it? to create value for our company and for our customers. What you do is you get all of that data, you start measuring that data in terms of volumes, in terms of capacity, quantity. You start monitoring the important feeds that are coming at you. You start building up your analytics platform as a company. And when you connect all of those three together, which is measure, monitor, and analyze, what you're bringing is actionable insights that you can specifically tell your organization what are the specific marketing campaigns that you want to launch, which products do you want to focus more, which products do you want to focus less on. Before we glide into the big data concepts, I think it would be interesting to look at three different industries and three separate use cases, and how these industries or these companies have used the power of data and big data to transform in how they reach out to the customers. The first of the use case that we're going to look at is Vail Resorts, high-end ski resorts. Just to give you an overview, it's a 20-year-old publicly traded company, stock ticker of MTN. Very interesting company in the hospitality industry, about $7 billion in market cap, and specifically a stock price that has increased 160% in the last 5 years. Current stock, I think, is running about $188. The next one that we are going to talk about is Brooks Brothers. Brooks Brothers, again, a privately owned 200-year-old Manhattan-based company. Estimated revenues around $820 million. They've been one of the leaders in high-end men's formal clothing for a long, long time, 200 years. Recently also diverged into women's clothing as well. The third use case that we're going to really look at is Northwell Health. I thought healthcare would be interesting to look at in terms of big data. Northwell is a Long Island-based healthcare network. They have about 21 hospitals and a medical schools, and revenues of approximately $5.5 billion. So let's just dive in and look at these use cases. The first one, like I said, Vail Resorts. The tagline gets very interesting: experience of a lifetime. Now, as marketers, the tendency is always first, you want to know who your customer is. Who are you selling your product to? As you look across the screen, we can easily figure out Vail Resorts is typically the young, affluent, and a family-oriented person, and coming from markets which are necessarily not even close to their core ski resorts. Most of their core ski resorts are based out of Colorado. What I wanted to highlight is how did Vail come up with such an increasing value in their stock price, increasing your stock price by 160% in 5 years. What they've essentially done is they've used the power of data to build relationships with their customers as they went along the way. For example, what they've done is they kind of track your customer, they track all the customers in terms of where are they skiing, which slopes are they skiing, what are they doing when they stay on the resort, the usual demographic details, and a lot of other details. What they do is they combine all of this data, they analyze and model, and then they start segmenting based on likelihood to visit, purchase, repeat, and you take that data and they kept evolving themselves constantly. What you want to see here as a marketer is traditional modes, which is your segmentation of customers, slicing your market base. That part does not go away. Just because you've got big data, that part does not go away at all. But however, what you're using is the power of data to actually refine the segmentation and slicing of the markets further. Just to close in on Vail Resorts, what they've done and what most of the organizations are trying hard to do is to build a culture of personalization. What you want is make sure that you're touching every single customer at a personal level. How they've done it is very interesting. They have RFID tags for their season pass holders, with which the skiers and riders can capture their experience and share their stories across their social media. For example, your Facebook feeds, creating images, videos, blogs, and everything else that we could imagine. And for Whale Resorts, they're basically turning happy customers into their brand ambassadors, in effect, trying to offset their marketing costs as well. And very interesting concept. You understand your customers' behavior using all the data, motivate them. You create a relationship umbrella, so specifically targeting the customers. And your most of these successful companies are using real-time information to guide customers as well. Just at the bottom of the slide, you'll see a quick update on what Whale is doing. They have about 75,000 or even more season pass holders. Each season pass is about $1,000. You pay the revenue upfront. There's been a 12% CAGR increase in the season pass holders year over year. Their stock price, again, like I said, risen about 160%, and they've seen a tremendous revenue growth just by using data on how to impact their marketing. Let's move. Let's move on to our next example, which is Brooks Brothers. Brooks Brothers, very interesting. Traditionally, a 200-year-old privately owned company. They've got about 600 stores across the world. What they are known for is their high-end customer service and high-end clothing. And when you go to their stores, it's all pretty much white glove customer service. There's a lot of hand-holding and customization that's done. And what they wanted to do was, how do we transfer this white glove customer service into a digital experience? And that is what they've done using data very seamlessly. What Brooks Brothers realized about 4 or 5 years ago is you've got to have a 360-degree view of the customer consistently. It's not just the stores, it's not just the customer behavior in store, but it is also about a lot about the connected customer. How's this customer browsing online? Where is this customer spending his or her time on the social media? Time spent looking at items versus buying. With that, one of the very important metrics that Brooks Brothers has focused on is the conversion rate optimization. Now, what is conversion rate optimization? It is nothing but if you have how many people that come to your site actually end up buying your stuff. You could have 200 people coming to your site, but if only 5 people are buying your stuff, then you have a problem. And they've used this connected customer and 360-degree view to make sure that the conversion rate optimizations have gone much higher. Lastly, again on Brooks Brothers, what they did was they identified their customer behavior across 11 dimensions, from an in-store to how a person searches about Brooks Brothers through Google search, or comes to a website, mobile app, and so on and so forth. What you're seeing on your screen is all the 11 different dimensions. And they used the data and analytics to bring all of these dimensions together to create an individualized customer experience and create their marketing campaigns accordingly. I'll move on to our last use case here, which is Northwell Health. Like I said, they're a Long Island-based healthcare network, 21 hospitals, and a medical research center. Very interesting. We all talk about the 80-20 rule, but very interesting how Northwell came out and says very openly about how 10% of their patients represent 60 to 70% of their spend and resource utilizations. I think a lot of companies struggle with identifying what is their core 10 or 20%. How can we focus on those customers? In this case, how can we focus on those patients so that I can reduce my 60 to 70% of spend and utilization? In other words, how can I reduce my COGS and the time and money spent? Northwell focused across 3 dimensions using data, which was profitability, performance, and patience. What they did was they identified trends among patients that leads to readmissions. Believe it or not, for most of the healthcare operators, one of their biggest resource utilization and costing comes from patients who get readmitted into the facility. That is not a revenue generation for them. That is an overhead and an additional cost. What Northwell did was they took all of the data on which are the patients that have a higher chance of readmission, which are the patients that consistently get readmitted. They created a separate team to reach out to these patients, have a separate counseling session, do separate campaigns for them, reach out to these patients and customers separately, and they reduce the readmission rates. In turn, you increase your profitability. The second one was focusing on performance. Most of these healthcare operators have data. However, they struggle with how do we use this data. What Northwell did was they picked up all the data that they have across all of their physicians and hospital staff. They started tracking the performance of these people because inherently this data, the physician's performance data, was relating somewhere to patient readmissions and low satisfaction rates. And once they started tracking and doing performance metrics, again, you can align your campaigns accordingly. Last but not the least, the most important customers, patients in this case. What you do is you have all the clinical data for the customer or the patient right from the day he or she got admitted to every single test and every single medication they've taken. There are a couple of things that you do with this. For example, what Northwell can do is they can use all of this data analysis to figure out which are the medications, which are the facilities I need to improve or work upon. On the other hand, you can work with a pharmaceutical company, sharing this patient clinical data analysis with them, and then start figuring out how to get better care, better medication, and better care for these patients. So it works out very well for Northwell. As we move along, let's look at, I thought it would be interesting to look at a quote from the guru in big data, Eric Schmidt, one of the founders of Google. Like he said, from the dawn of civilization until 2003, we generated 5 exabytes of data. Now we produce that much amount every 2 days. For those of you wondering what is an exabyte, well, here's 2 different definitions. 1 exabyte is about 1 into 10 to the power of 18 bytes. For those of you still wondering, here's another definition. 5 exabytes of data, which we generate every 2 days, is about every single word that every single human being on earth has ever said. So hopefully that gives you an interesting insight into how much data we generate. Let's get into the foundations of big data. There are 4 V's of big data that are very core: volume, variety, velocity, and veracity. What is volume? Volume is the data at scale. We've seen on our first slide on how much volume we generate, how much data do we generate every single minute. And with big data, that is the volume. If you're an organization, that is the volume that you're dealing with. Variety is the data coming in different forms. There would be structured data. For example, if you're an organization, you could have data coming from your sales force, from your accounting and your financial systems. You could, and your CRM systems. At the same time, you could also have unstructured data, which is coming from your social media feeds, like a Facebook or a Twitter feed, or somebody blogging about you, or creating videos and sending images. So it's data is coming to you at in different forms. How do you get them together is always a challenge. Velocity is data in motion, or the speed at which the data is coming at us. Because of the speed at which we are operating nowadays, and because of the social media and how easy it has become to just upload an image or a video, record a video, the speed of data has increased tremendously. And a lot of organizations have, while they have a lot of variety of data, at the same time, all of these different forms of data are coming at you at a high speed. Veracity is about the data uncertainty, which is how do you rely on this data? For example, if I am an irate customer and I didn't like your product, I just went on to YouTube, I created a video and I just put it on YouTube, right? How do you trust that what the review that I've given is actually true, or is it just an irate customer? Uncertainty of data is a big issue. To give you some numbers, 1 in 3 leaders which is about 33% of the leaders, do not trust the quality of data that comes at them. So let's just move to the concepts that I'm going to talk to you about in this session. There are a lot of concepts. The 4 core concepts that I'm going to be talking about is cloud computing, Hadoop, machine learning, and Spark. What these are is all of these are the frameworks or the base. They form the base of your big data analytics as an organization. You have all of these in some of the different forms. They form the base. That leads to, as a marketer, you're leading up to, you want to make sure how do you use all of these to reduce your costs? How do you increase your speed of decision making, almost like real-time decision making in some cases? And then how do you help use this data to launch new products and services? And then at the real end of the spectrum lies the 3 core types of analytics, which is your descriptive, predictive, and prescriptive analytics. We'll talk about these as we go up. So the first one is our cloud computing. What is cloud computing? Think of it this way. A lot of you might be having servers in your organizations. Think of it, when you want to grow in, how much time does it take to add an additional server for your company? And now think of it, what if I told your company, you don't have to worry about adding server capacity anytime. Let's just go to a cloud platform, let's say, whether it's Amazon Web Services or Google or Azure, which is Microsoft Cloud. And let's say if I'm Amazon, I will provide you all the servers. And what you just have to do is you pay as you go. And every month you keep paying for whatever capacity that you're using. If some months you do a massive layoff and you start using a smaller server capacity, you go with the smaller capacity in that case. That's just for infrastructure. A lot of companies have started giving you software as a service. For example, think Salesforce. You don't really have to come and have someone come and install Salesforce in your company. You just log into a browser, you configure what is essential to you, and you move along. And that's called software as a service. The last one is platform as a service. Think of it, you might have data scientists in your company or programmers or coders. Now these coders need a basic server and operating system and some kind of special software so that they can do coding. What if I would provide you the server and the platform so that when your developer or your data scientist comes in, they can immediately start coding, no basic setup needed, right? That basically is your cloud computing, having some other company or someone else manage all of your infrastructure. It could be software and or platform to rapidly deploy applications. It's all about doing faster, better, and cheaper. The next concept I want to talk about is Hadoop. What Hadoop essentially is, there's a lot of talk about Hadoop, and whenever you think big data, I think one of the buzzwords that comes to your mind is Hadoop. Hadoop is basically, think of Hadoop as an open source data storage and processing. It's a framework, it's an infrastructure. Let me give you an example. Let's say you have a large file, say you have 1,000 pages, right? And have one person come to my room, I give that person 1,000 pages and say, okay, can you count the number of words in this file, right? Now for that one person, it's going to take a long time to count the number of words because he or she is going to go in a serial mode. Now, as opposed to it, let's say I take the 1,000-page file and I have 200 people sitting in my room and I give each one of them 5 pages and say, okay, each one of you just count the number of words in your 5 pages, give me the number. Each one of those 200 starts giving me the number. At the end of the day, I just do a total and I'm done. Again, I would have done this much faster with the 200 people. Let's apply that to Hadoop concept. It's the same concept. Instead of the 200 people, think 200 computers. You have one master computer. It operates in a master-slave mode, which is one master computer, which will tell all of its 200 computers what is the task that you need to do and how you're going to do it. So it will tell the process on how to do it, and it will tell the specific task. And all of these little 200 computers, which could be very commodity computers like a regular slightly powered laptop, and these laptops or these processors will start processing the data. And that's mostly the core concept of Hadoop, which is kind of map reduce. You split the job into n number of processes, you split it apart, and then you just bring it together at the end. Hadoop has been, again, a very, very useful architecture if you think of in terms of marketing. Think of it, you have a lot of customer data, tons of customer data. You have your in-store data, you have your online data across different dimensions. How do you split that, process it, and bring it together? What you do is you store all of that data across the Hadoop architecture, which is split across different computers, and then you use processes like MapReduce to process the data much faster and bring it together. I wanted to, again, end the Hadoop part with a real example. What you're seeing is could be an architecture of an e-commerce site. So on your left, under the data sources, what you're seeing is the, say, website data, the content management system. You could also be getting data from an external web content where you've shared your data with. And you could also have user-generated content. In this case, if a user has clicked images of your product or shared information about you on Twitter or YouTube's, you have all of that data. You bring all of those data sources, you split that data across and store it in a distributed architecture across the Hadoop framework. And then what you do is you can use algorithms like MapReduce, where the process goes to each of these split different nodes or different computers, does its job, and brings the insights together. At the end of the day, as a company, you want to connect all of these different data sources, do your processing, and then figure out, is there certain relevant content-rich user-targeted landing pages that I can create? Those are the insights. Are there specific marketing analytics that I can do with it? So that's Hadoop in a nutshell for you. Moving on to the next concept, which is Spark. Now, what Hadoop did was very interesting, and it was very good when it started, which was split the data across, and then each computer does its own stuff. That's very fast and efficient. However, one of the drawbacks with Hadoop and MapReduce was every single time a process is done, it will keep writing to the disk. So think of it, if every single computer keeps writing to its disk, and if you have tons and petabytes of data, now that's starting to cost a lot of time for you. Now, along came Spark, again an open source. What Spark does is, instead of writing to data to the disk every single time for every single small part of the process, what Spark does is it will do all of this computation in memory. So now, since I'm not writing anything to disk, I'm doing the processing much faster. In fact, Spark can process up to 100 times faster than Hadoop and MapReduce. Spark has also improved usability because developers now have to write less code, which means once, as marketers, if you're giving a process or an operational concept to a data scientist, they are going to have to write less code. That's less time taken, but processing is faster. So that's interesting about Spark, and it has been one of the very successful things. The next one that I want to move up to is machine learning. Machine learning is interesting. We saw about Hadoop, MapReduce, and Spark. All of these are frameworks and architecture for big data, right? You just store it's all about how you store the data and how processing will be done, whether it will be done in memory or will you be writing to disk every single time. But what is machine learning? Machine learning is the processing of data. So once you have the data, how do you find the insights, and then how can you predict something? And that is what machine learning does. There are three core types of machine learning, which is supervised, unsupervised, and reinforcement. Let's look at the first one, supervised. what supervised does is it uses historical patterns in your data. Once you've given some data to the algorithm, it uses the historical patterns in the data to predict the values or customer behaviors in the future. And supervised learning most predominantly used in applications where past data can most likely predict your future trends. So think of e-commerce, retail. You can have a past data, you can pump that data in, and you can run these algorithms and figure out what's your sales pattern going to be. Or you can figure out based on a certain data that you sent in and a particular marketing campaign that you ran, and what is the prediction, what is the likelihood that a similar marketing campaign will be successful or not successful in future. The next type of machine learning is unsupervised learning. In this case, in the case of unsupervised learning, your goal is to explore, let the algorithm explore the data and find if there is a structure within the data. So in unsupervised learning, you really do not know whether you have certain cluster of your customers or you don't. Are there segmentations or not? No segmentations. You're not able to figure out patterns. You pump all of that data through the algorithm, and then you're trying to let the algorithm figure out the patterns. For example, unsupervised learning algorithms can identify segments of customers with similar attributes who can then be treated similarly in marketing campaigns, so that your marketing campaigns, the return on marketing investment goes up in that case. Or you can find what are the main attributes that separate customer segments from each other in my products. The last one in machine learning is reinforcement type. Reinforcement is often used for robotics, gaming, navigation. With reinforcement learning, what happens is the algorithm discovers through trial and error. So it takes a bunch of data, it does some trial and error, and then it figures out which are the actions that lead to the greatest rewards. You want to figure out the action and the reaction and which one connects the best. So that's it about our machine learning. Let's talk a little bit about the different types of analytics, which is the descriptive, predictive, and prescriptive analytics. Descriptive analytics is what most of the organizations are doing right now, which is basically you have all your past trends, and then based on your past trends, what you want to figure out is, can I figure out what happened? For example, I had my marketing campaign run in, say, 2015. What happened there? Which customers reacted better? Which customers reacted poorly in that case? Which products did I sell more? Which products did I sell less? Again, it's just telling you what happened in the past. Predictive analytics is when you have all of the past data, which you have pumped into descriptive analytics, but you take all of that past data and you run algorithms where you can predict what will happen in the future. At the very base, if you've done regression, even a simple linear regression is a form of predictive analytics. Because what you're doing is you're plotting a trend line, you're figuring out what's your best fit line, and you're trying to predict into future. Can I predict a Y value if I know an X value? The last frontier is prescriptive analytics. This is where most organizations want to be. That is the challenge of organizations. How do we get to prescriptive analytics? Prescriptive analytics is, okay, I know that based on my data, what is going to happen in the future? Which type of customers are going to come in and buy my products? Which are the types of patients that are going to be readmitted, or which type of patients am I going to get in my facility? What should I do about it? Can I get some guideline? Which areas to focus more, which areas to focus less on? And that's the toughest, and most organizations are struggling to be here. About only 10 to 15% of organizations are currently able to do prescriptive analytics. As we've completed the 4 core modules, what I wanted to do was I wanted to connect all of them together and bring it to you. We've spoken about our sources and data collection. We have our data from all of these different streams, from Facebook, Twitter, Instagram, and your traditional sources of CRM, sales analytics, you get all of that data. In terms of storage infrastructure, it's where your Hadoop comes in and how you're storing it. Most of the times, you're storing it in cloud, in the cloud. You're not storing it in physical servers in your organization. What you do is you use Spark and machine learning to actually process that data. You use Spark methods to make sure that the processing is done in memory. You might use one or more different types of machine learning, supervised, unsupervised, or reinforcement to actually get insights and do processing. And finally, at the tail end is the insights. You might be able to source the data and store and process it correctly. However, if you cannot show it on a dashboard, on a few reports in a smarter way, everything else will fall apart. A few of the tools that do good analytics or good actionable insights are SAS, R. Using R, you can do a lot of analytics. IBM Watson Analytics has been one of the new players on the market. And then lastly, but not the least, Python is, again, it's a programming language, but again, like R, you can do a lot of analytics and insights with Python. As I conclude, I want to bring you back to the original slide. We've seen a lot of our data. What is important is how you measure that data, how you source and collect that data, how you start monitoring it on a day-to-day basis, and then how you analyze and bring insights into it. What we do here at Baruch, just to give you an overview, as we do these courses, big data courses or analytic courses, we also conduct a lot of industry insights with the students. What it means is, for example, recently I led up an IBM data science bootcamp, which was a 5-day bootcamp where students attended the workshop along with our industry partners, like a lot of our financial services firms. Their employees also came in. So it was a hands-on workshop where students and corporates sat together. And at the end of the 4 days, students walked out with an IBM certification, certificate and a badge. We also do a lot of SaaS workshops and some other industry tool workshops, just so that as you're navigating through the course, you can connect the methodology and the concepts that we are talking in our courses with what actually happens out there in the industry. With that, I'm going to hand over to Professor Andreas Grein, who will talk to you about the course structure and in detail.
Yes, so hi everybody. My name is Andy Grein. I'm a professor of marketing and international business, and I'm also the academic director for the Executive MS in Marketing. I wanted to welcome you all today and also thank Maithily for her great introduction to big data. And I hope this has maybe whetted your appetite to learn a little bit more. So the first thing I'd like to do is just tell you a little bit about our department. This is actually a very large department of marketing, and very well known for publications as well as teaching. And I just wanted to highlight that for a student, the reason this is important is the larger the department, the more sort of faculty knowledge and resources that can be brought into a program, both sort of curricular and extracurricular. And, Maithily mentioned some of these workshops that we're doing as it's a very valuable add-on to your education. At the bottom of the screen, I'm showing some of the websites, just if you want to learn a little bit more about our department. And of course, the last one is the link to the website, which actually describes the new Executive MS in Marketing. So just to tell you a couple of key things about this program, is a very fast program in that you're completing a 30-credit MS in 1 year. It is very flexible in the sense that if something comes up, such as a work emergency or a family kind of problem, this happens once in a while with students. If you have to miss a module, you're actually able to complete it with the next cohort. And hopefully that won't happen, but there is some flexibility built into this just in case. It's very efficient in the sense that you have 2 days of class on 2 weekends per month, supplemented with online learning. And I just wanted to point out that, you know, in terms of the time commitment, this also means that the program is sort of feasible for students who may not actually live in New York City and have to commute a little bit further. The time on campus is a bit more limited than normal. It's very dynamic in that we're focusing on the latest things, and it's global, and I will talk about the global element in just a minute. So to go a little bit further, just so you are familiar with what executive style teaching is like, this really is an enriched learning experience in the sense that, you know, you get information from the faculty leading the course, but a lot of what happens in executive programs is the networking that happens between classmates. And this is something we really want to encourage. Your classmates actually have a very wide range of experience and background that they can share with you, and the learning happens student to student. There's a digital marketing and analytics focus, which is a very hot topic nowadays. There are business communications and consulting capstone courses. It's something that employers tell us they really wish they could find better skills among the student body. So it's a very important element. The international trip is how we globalize the program. It's actually a course in international business supplemented with a trip. The trip is fantastic. I can tell you more, but just to sort of give you a teaser, just got back from Singapore and Vietnam. It was just wonderful. So what we're really doing is offering a lot of breadth and depth for marketing professionals who want to go further in their career. So the module structure is actually blended learning. So there is pre-work online, which is your preparatory and first kind of assignment work. That is followed by 2 weekends of class days, Saturday and Sunday all day. This is where all the face-to-face stuff happens, as well as groups and presentations. And then the post-work online is when you complete projects and do any sort of assessments. And there is about a 2-weekend period between modules where you sort of rest and recover before the next one starts. It is a very intensive experience. So the course structure, this is actually a listing of all the courses in the program. Just wanted to focus on the sort of more advanced part, which is the digital marketing, web analytics, and even things like branding. And then, of course, the capstones, the international trip, and the business communications and consulting. And besides the course structure, this is, supplemented by any sort of extra stuff you can do on campus while you are here. We know everybody's really busy, but some of these things like the industry workshops that Maithily mentioned, some of these are really very important add-ons to a program, and you can take advantage of this while you are a student. So just to sort of sum it up and round it out, these are some of the faculty who are involved with the program. These are kind of our stars. Of course, we have a lot more faculty, but these people are all selected for not only their experience in research and industry, but also their ability to offer a really good course to our executive students. And then the last thing I just wanted to show you is some contact information. Feel free to contact me at any time with questions about the program. Any sort of question is fine. Kate is our admissions person, and she can help you with those questions. And of course, our presenter, Maithily, is here as well in case you have any questions about her topic or about life at Baruch in general. So again, thank you very much, and happy to see what you guys think about our program.
All right, thank you very much. So we're going to now move to the open Q&A portion of our presentation today. Maithily, first question that came in is if you could share a bit more about some details surrounding prescriptive analytics, and maybe if you have a few examples you could cite.
Sure. Prescriptive analytics, one of the interesting examples that I've seen is, again, I'll cite healthcare first. For example, you have predictive analytics can tell you based on the number of patients or based on the past, how many number of patients are going to come in let's say let's take the example of only the emergency room. How many number of patients are going to come and check in into the emergency in a given day or within a month starting next year? That it can predict pretty well. But then you want to know, what do I do about it? Which areas how do I focus into it? Like, do I focus more on just the general physicians or the orthopedics or the cardiologists? So that's basically an example of how do you use prescriptive analytics to guide you and get you into insights. Um, Another example is basically, let's take finance industry. For example, fraud detection, right? So based on the ton of data that you have, a lot of these corporates are able to predict how many the financial organizations are able to predict how many people might end up being a fraud. How many of my customers might do some sort of fraudulent activity. Now, I know that particular percent. What do I do about it? Now, what that translates really into is, do I need to create a separate team to reach out and talk to these customers and engage them beforehand? Do I need to just up my security levels in the organizations? Do I need to create separate banking areas to address these things? Those are the kind of questions you're trying to solve based on what you know is coming at you.
All right, thank you. The next question, you spoke about data scientists a few times during the presentation. Could you share maybe a bit about the differences between the roles of a data scientist and perhaps like a marketing analyst?
Sure. That's an interesting question. Comes across a lot of times, especially when we try to address marketers and who want to deal with a lot of data, right? Here's the difference. When you talk about data scientists, those are the guys or people who are going to actually write those algorithms for you, think of which algorithms need to be used to resolve your processes. To understand, for example, to understand your data patterns, right? You have a lot of customer data. To understand the data patterns, which algorithms need to be used, programmed, they are the ones that are being done by the data scientists. When you talk about a marketing analyst or a data analyst, you will be, as a marketing analyst, you will be the person who will be bridging the gap between your business users and your data scientists. On one hand, understanding the business, on the other hand, translating that into some form of what are the specific patterns that you're looking for. So what you do is you tell the data analyst, these are the 10 patterns I'm looking for. Can you work with me? And from that point onwards, the data scientist takes and figures out which algorithms and does the coding part. So you would not be the coding part, you would just be figuring out which are the patterns that you want to identify.
Thank you very much. The next question I have perhaps would be for you, Andreas. You mentioned that there's a very blended learning experience in this program. We have a question from Adil in the audience who wants to know a bit more about what the online learning environment is like.
Sure. I mean, every class is different. That depends a little bit on the instructor. But what we are trying to do is shift some of the tasks involved in the course out of the classroom and online. Typically, we'll use a platform like Blackboard, which is just a way of making information accessible to students. And then some of this is just download the article and read it, maybe write an assignment, submit the assignment. There can also be live elements where you're actually submitting questions and getting a response, or maybe like a mini lecture online. But the idea is that, you know, because students' schedules are so tight, that if we can reduce the amount of classroom time and make things a little bit more flexible by putting them online, that it really helps students get control of their lives. And, you know, we all want control of our lives.
Perfect, thank you. Maithily, the next question I have for you, this is coming from somebody who's at a software company, and they're trying to provide services to e-commerce clients for big data. What should they keep in mind down the road as they look to do this?
Well, if you're trying to provide services to e-commerce, a few things that come to my mind straight up, and which we've done in my industry experience as well. The first and the foremost is you want to make sure data security is at the top of your priority list. Because for e-commerce retailers, you have all your customer base online. We've seen credit card frauds happening, big card frauds happening. So data security in terms of your customer information, your financial information, all of that stuff is secured. Even also the products that you're trying to that the e-commerce retailer is trying to sell. So data security is one. The other thing that you want to figure out is which are the different geographical zones that your e-commerce retailer is trying to sell across. Because latency, which is data latency, which is like how much time does it take for when you send a data and how much time does it take for it to come back over the network, internet, that becomes an issue across geographical regions. And that's where cloud computing can help you in a big way. For example, when you host for your e-commerce retailer, when you host on the cloud, even let's say on Amazon, you can specifically tell Amazon Cloud which locations do you want the data to be replicated and hosted on. So if the e-commerce retailer is across Asia, Europe, and say just on the east coast of US, you want to probably have the data hosted somewhere in the Philadelphia Northeast region. You want the data to be hosted somewhere in the UK, Ireland region, and then you want the data also to be hosted in the Singapore or Southeast Asia region. That helps you a lot. So data security, how your data is spread across. The other thing is what applications and the ease of software that you're giving them. Because when you give software as a service or services to a client, the ease of adoption is a big factor in how you can use your data wisely. So I would say those are the top three priorities I would focus on. Of course, there are a lot others, which is like what is the compatibility of the software and how the organization is operating, and all that stuff is there as well.
Okay, thank you. The next question, either Maithily or Andreas, you might be able to answer, but in terms of job readiness, what kind of prerequisite knowledge or skills do professionals need in the modern workforce to be able to use big data effectively?
Well, in terms of job readiness, if you're a marketer or in marketing analyst, I think what you need is, apart from the core marketing skills that you need, that does not go anywhere. In terms of big data, what you definitely need is a deep an understanding of what big data is about, the different tools and different terminology, to be able to talk to your data scientists and your technology team in a much more conversant way. So you need that. You need to definitely have a lot of hands-on on a few analytical tools, which is what we do when we do the industry workshops. That is our idea, so that when you say graduate from Zicklin, you have had hands-on experience, say for example on IBM Watson or SAS Analytics, and you've got certificates to prove to employers that hey, you're not just writing something on your resume, you actually have done some real work. And I think hands-on workshops or hands-on experience with the tools and the ability to talk big data terms and understanding them is what is going to get you much more prepared for the job scene.
If I could just jump in, I mean, in executive programs, we say, you learn it on Saturday and use it on Monday. And it's not just a slogan. I mean, the students have validated that and said that it's really that useful.
Great, thank you very much. Next question would be, can you explain a little bit about the difference between machine learning and artificial intelligence?
Sure, that's an interesting question. I'll start with AI, artificial intelligence. Artificial intelligence has really been around for a long, long time than we actually know. It's basically artificial intelligence is nothing but trying to build technology that starts behaving like a human. right? Robots are nothing but AI. Self-driving cars, Siri, smart homes, many other technologies are classic examples of artificial intelligence. Machine learning is essentially a subset of artificial intelligence. Basically, what machine learning does, as we saw in the supervised, unsupervised, and reinforced learning, is machine learning uses algorithms that to learn from data. So while artificial intelligence, you're just taking and building up technology, machine learning, you're using the data that you already have to start finding patterns and predicting into the future. Algorithms are nothing but a series of steps that lead to a completion of a task. How do I get from point A to point B? That's an algorithm. So that's a core difference between AI and machine learning.
Perfect, thank you. Next question. Andreas, you had mentioned earlier about a trip to, I believe you said Singapore and Vietnam. Can you tell us a bit more about the international trip that's part of the Masters in Marketing?
Yeah, sure. I mean, this is probably my favorite topic. This is actually a course. It's a basic international business course. And that means at the end of the module, you'll get a grade for it too. So it's not all just fun, but it is a course, international business, focused around the trip destination. And so you get some stuff in class. There's some assignments, and then when we go, it's roughly a week and a half with travel time on both ends of company visits and also some cultural events, because part of international business is actually understanding the culture of where you're going and not just the business environment. Destinations vary. We've been going a lot to Asia in the past. We also visited South Africa last year and Latin America a few years ago. India and Dubai was another one of our destinations. The students tend to rave about it. It's really just an awesome experience, and largely because it's not just the destination, but the quality of speakers that we get give us insights to business and to marketing that you would never get by sitting in the classroom. You literally have to go there and see it and hear what these people have to say to understand it.
Fantastic. Well, thank you both very much, as well as a big thanks to the Zicklin School of Business at Baruch College. This has been a wonderful presentation, Maithily. We really appreciate it, and thank you, Andreas, as well for your time. Before we sign off, any final thoughts you'd like to leave our audience with?
I just wanted to mention that we have an admissions open house this Thursday evening, and if you want to come down and meet us, drop me or Kate a line and come on down. It would be a pleasure to meet you in person and happy to answer more questions.
Great. Well, thank you very much, everybody. Again, you can reach out to the team there. You'll see their email addresses. Thanks again. Have a wonderful day.